Sasina, Professor Vikram, Dr. Shyam Sundar, Professor Raja. I'm privileged to be here from ONGC to present this presentation. I had worked for subsea maintenance activities for about more than a decade and a half in ONGC, and based on my personal experience, I have made this presentation and I'm sharing it with you. In 19th century, we were using human power and the steam, and then came the oil. Over a period of time, oil and gas has become fuel of choice. A major challenge associated with extraction and its use is its transportation, and pipelines have proven to be the safest and the efficient mode. Basically, pipelines are lifeline for the oil and gas industry. Pipelines used in offshore applications are subjected to high stresses. Nature of fluids and the length of the pipeline, the type of terrain, etc. are major considerations for design and subsea pipelines. The subsea environment provides conditions ideal for hydrates, wax formation, which are not desirable. The problem of design procedure is to find a pipeline configuration and size within the constraints which is safe and economical. Offshore pipeline design differs primarily in requirements of environment and installation process. In offshore, these are the major subsystems. We have the subsea wellheads, the platforms, plams are the pipeline end modules, the SBMs, single buoy moorings systems, and the pipelines. OSD has a definition for the pipelines which says that these are the pipelines which carry crude from the producing to the platforms or from platforms to the end for the processing. The subsea environment presents numerous challenges for the pipeline. This highly corrosive, marine growth on the pipelines, geological hazards, environmental impact on the event of the leakage. To mitigate these challenges, subsea pipelines are designed with more safety factors, redundancy, and the monitoring system. So basically, for laying, we have different techniques for offshores. What we call as S-lay technique, wherein the pipeline is laid in the form of S shape. Then we have a J-laying method. In addition to this, we have the pipelines wherein they are spooled on the reels, and with the help of vessels, they are laid on the shore, say offshore. And these pipelines are of smaller dia, up to around 12-inch dia, and are most of the times these are the flexible pipelines, and rigid pipelines are of lesser dia. Then we have this technique also wherein the prefabricated pipelines from the yards, they are towed in smaller segments and gradually load in the seabed. So these are the pictorials wherein we can see the subsea terrains through which the pipelines are moving out. So the pipelines are exposed to seabed irregularities, incorrect installation procedures, external forces, subsidence, free spans, corrosions, and erosions. Then there are different types of threats which the pipelines face. It could be the man-made as well as the natural. So man-made, when we are talking, it could be the anchor handling, the anchors of other vessels. They could damage to the pipelines, fishing trawlers, fishing nets, and it could be even sabotage also. The natural threats, the natural disasters, the pipelines may pass through the areas prone to the underwater disturbances, cyclic stresses, cause the fatigue in the pipelines, and the corrosion. Pipelines are constantly exposed to the corrosive elements, which could be internal as well as the external. These are the corrosion. Fundamentally, we all know, since morning we have been discussing about the corrosion, and the ONGC is not different than the other industries as far as the corrosion is concerned. And in industry, we will have more corrosion occurring because of the other than the crude factors, crude oil and gas. External corrosions, the pipelines, they are exposed to the salt water, splash zones where the oxygen concentration is on the higher side. Then the microorganisms, they colonize and destroy the pipelines. Chemical reactions between the pipelines, water and the dissolved substances. We have galvanic corrosions also. Subsea pipelines are exposed to abrasive forces also. To mitigate such external corrosion, various preventive measures are implemented. So these are certain pictorial depictions where in the pipeline you could see the extensive damages being caused to the pipelines. The internal corrosion is because of the contributing factor for the internal corrosion is the water, carbon dioxide, and the hydrogen sulfide. Internal corrosion, it could be flow induced corrosion also. Solid particles such as sand and can also be the abrasive wear on the pipelines. Accumulation of solid deposits in the pipeline can create O2 concentration leading to the corrosion. So these are again the in pictures you can see the pipeline wherein there is a flow is because of the diameter the water marks are clear cut shown. The biochemical corrosion is one of the serious corrosion which we are finding in our pipelines. These are the biochemical corrosions. Degradation results from the micro or macroorganisms. These organisms can live in different atmospheres and temperatures, and these attach themselves to the walls of the pipelines and cause crevice type corrosion. These are the pictorial depiction of the failures we had come across. These are the actual pictures from ONGC. Prevention and mitigation programs are more or less on the similar lines as it is for any other application. So it goes with the proper material selections, strategies to remove water stagnations, improving upon the operating practices, that is by pigging and other things, applying barrier coatings, paintings, cathodic protection, forming of protective films with the help of corrosion inhibitors. Prevention, the personnels involved are also to be trained to take care of the consequential internal corrosions, regular inspection and the monitoring techniques such as pigging, probes and remote monitoring, implementing of preventive measures and monitoring strategies to ensure the integrity of longevity of the subsea pipelines. So again, similar as in any other industry, the material selection and its prevention by other techniques is to be taken care. So here again the choosing material that are inherently resistant to corrosive environments present in the oil and gas pipelines help to minimize the risk. But it does not remove the risk, but it just helps in minimizing the risk by selecting appropriate materials for the cathodic protection, fluid properties, operating conditions, presence of corrosive agents, temperature fluctuations, etc. Chemical treatment play a vital role for corrosion prevention of pipeline by inhibiting corrosion process and removing the potential instigators. This helps to ensure the integrity and longevity. Chemical challenges for chemical treatment. If it is not handled properly, it can cause a risk to the marine ecosystem. Chemical treatment of pipeline is expensive. It is essential to optimize the treatment process to ensure cost effectiveness without compromising the efficiency. Subsea pipelines are located in remote locations, making it challenging to assess. Applying barrier coatings, paintings and linings to the pipeline's surface, forming a protective film on the metal surface by corrosion inhibitors. Materials must be able to withstand the harsh environment conditions and maintain their effectiveness over time. The interaction between different chemicals, inhibitors and the pipeline material can sometimes lead to the unexpected reactions or compromise the integrity of pipeline. Effective planning, specialized equipment and adherence to the best practices are essential for successful chemical treatment. Inspection and maintenance practices, it is as applicable for the onshore pipelines. We are also following the similar type of pipelines, practices, pigging, intelligent online pigging for the pipelines. But again, subsea pigging is a challenging job because of the infrastructural constraints. Normally pigging, it helps the way it is helping for the onshore pipeline, it is helping us also to know the health of pipeline by analyzing the debris or the deposits being recovered from the pipelines. Normally pigging, as we understand, it is to be carried out throughout the life cycle of a pipeline, right from the construction phase to the decommissioning phase. The various scenarios what we come across in the industry is the corrosion is well known in oil and gas industry. Pipeline corrosion occurs naturally due to the degradation of continuous environmental attack on the pipelines. Sometimes critical components such as flanges etc. have remained largely unchanged a study by NACE, it is an old study wherein the figures in USA itself is ranging between 5.4 billion to 8.6 billion. So while you are reading this particular line itself, 760 kilograms of iron have corroded. So this is the magnitude which we can understand. Every year in India, around 4% of GDP. It's again, sometimes back this year, figures were shown in some of the magazines. About 80% of steel produced goes into the replacement of corrosion of damaged steel. This leads to depletion of associated natural resources such as metal, water, energy. Corrosion represents about 25% of the maintenance cost. Corrosion increases maintenance and repair cost. In extreme cases, extensive corrosion can lead to the need for the entire pipe section or even entire pipelines to be replaced. This requires significant investment in materials, labor, and logistics, resulting in substantial financial implications when it comes to the offshore industry, because a lot of resources, logistic resources are required for the same. Corrosion in pipeline can also cause unplanned shutdowns and reduced operational efficiencies, leading to the loss of productivity. It can lead to the leaks, spills, potentially causing the environmental pollution and damages. Remediation and environmental cleanup costs can be substantial. Failure to comply with the regulations can lead to penalties and fines. Corrosion related incidents can result in increased insurance premiums for the pipeline operators. Pipeline corrosion incidents can have long-term effects on the reputation and stakeholders confidence in the company. Investing in corrosion prevention and mitigation strategies and regular inspection can help in minimizing the financial impact of corrosion. So these are some of the pictorial depictions wherein we have come across the pipeline as practically split at a 6 o'clock position, about to complete. So these are again the pictorial depictions, the pinhole clamps and the crevices type corrosion in the pipelines. So normally whenever a pipeline is there, it needs different type of strategies to be maintained: repair, refurbish, and replace. So repairing a pipeline in offshore is a very tedious, and different type of resources are required. Dynamic vessels or barges with the addition to the diving expertise is required for offshore pipeline repairs. With this I conclude my presentation.
Any questions? One question, maybe. Let us thank the Kalsi for the good presentation. Thank you very much, sir. Thank you. Thanks a lot.